Hi, I'm Jolene. I'm from Team 27 and I will be presenting our team's solution, which is the Smart Home Energy Management System. First, the introduction. The team decided to do an energy management system is because we saw the recent news of the rising increase of gas and electricity prices, which then led to a rising demand for energy-saving solutions. So therefore, we actually look at existing smart home energy management systems, and we realized that there's a very limited coverage due to the communication protocols that they use. So in order to improve the current system, we then use these following communication protocols, which is the Wi-Fi mesh, Bluetooth, MQTT, which is the Tuya plug, together with the UI, which is the Flask. Now onto our project overview. So for this project, there is two main objectives, is for the system to be both power efficient and time efficient for the homeowners to use. In order to fulfill these objectives, the team then implemented these four main features. Firstly, the team used energy monitoring sensors together with a smart plug to monitor and capture the data of the energy used by homeowners, in which we also use reliable communication protocols and a user-friendly interface which enables homeowners to control and monitor their devices remotely. Now we're passing the time over to Javier to talk more about the software and hardware.
So now for the hardware and software. For the hardware and software for UI, we use the Raspberry Pi and Flask. So this is our main UI. For the communication protocol, we are using Wi-Fi mesh. So it uses the AC sensor, the DFROM sensor, the M560 Plus and PicoW, and the software we use is the Arduino IDE, which is C++ and SQL database. So for this one, we get data from the DFROM sensor, and then after that we will transmit it with the M560 Plus or the PicoW. So now for the MQTT, this one we use the Tuya plug and the Raspberry Pi together with Tuya MQTT and Tuya CRI, which are APIs, Mosquito, and the Tuya IoT platform. So Tuya MQTT is a workaround for the Tuya IoT platform. So we can get the readings for power, voltage, current, etc. And last but not least is the BLE. The hardware we use is the M560 Plus and the PicoW, and the software we use is the ESP-IDF.
So now we're moving on to the IoT in action portion. So first I'll be talking about the relevant scenarios, and first up I'll be talking about energy forecasting and predictive analysis. So by analyzing the historical energy usage data, the system can predict future energy demands more accurately, which allows for better planning and optimization of energy usage, which will overall reduce energy consumption. So next is user engagement feedback. Since we place a large emphasis on user engagement, this is very important. So we provide real-time feedback to homeowners on their energy usage and efficiency efforts, which can be delivered through mobile app or smart displays, which is our UI, and empowers users to make informed decisions about their energy consumption and adjust their behavior accordingly. So next is the appliance control and automation. So for this one, it is currently not implemented, but smart home systems can automate the operation of appliances and devices based on predefined schedules, occupancy, and energy pricing. So for example, maybe in the future, after having the history of energy forecasting, they'll be able to predict when to automatically turn off the lights, adjust thermostat settings. However, this still requires smart devices, which may not be available in all in all user settings. So next is the integration with renewable energy sources. So if the home has solar panels or renewable energy sources, the system can optimize the usage by combining energy production and consumption. So it can also prioritize using renewable energy when it's available and switch to grid power when necessary to maximize cost savings and reduce reliance on non-renewable sources. So next, I'll be talking about the interactions between our devices. So as you can see in the diagram, we'll be focusing on two network topologies, Wi-Fi and Bluetooth. So referencing to the figure, each of the 4 Tuya plugs will be directly communicating with the router using Wi-Fi following the star topology and will not communicate with each other. Thereafter, this router will communicate with the Raspberry Pi, which is in charge of the home assistant system, which is the UI. And then for the Bluetooth mesh at the bottom section of the figure, there are 2 M5 Stick C+ and 1 Pico W device, which will be communicating through a mesh topology using Bluetooth and are interconnected and can communicate with each other. So by utilizing these different types of IoT devices, we can show that this system is compatible with communicating across different types of IoT devices. And these 3 IoT devices, the 2 M5 Stick and 1 Pico, will communicate with the Raspberry Pi, ideally based on the shortest distance to the Raspberry Pi. And lastly, the Raspberry Pi will connect to the DF robot, which is our AC current sensor in charge of measuring current and sending the data back to the Raspberry Pi for further analysis and visualizations. And now we're moving on to the conclusion. So for the conclusion, we have found these benefits, which is reduced energy usage. And this reduced energy usage will also provide an impact on the environment, a positive impact on the environment. It also allows for decreased household costs as the user is able to control the energy usage more efficiently using our UI. And this will result in large cost savings for them as well, which is very beneficial. And also the increased awareness. So by using the UI dashboard as shown, the statistics provide users with smart tips and insight on appliances. So this can also help them in not only reducing energy usage, but also like understanding how much each device uses. And maybe in the future, they can get appliances which rely less on energy or get more renewable energy appliances. So next up, how we can apply this smart energy management in different contexts. So rather than just residential settings, we can also apply them in school campuses. So by monitoring the energy usage across various buildings, facilities, and dorms, this will also help the school to understand which portion is taking up more energy. And by leveraging on that, it can also reduce costs. And then another context could be office buildings. So by monitoring and analyzing energy usage patterns across different areas like lightings, HVAC systems, and office equipment, they are able to reduce costs and also help them to understand which portion is taking up more energy as well, which will be beneficial for reducing costs as a whole. Yep, and that's all for our project. Thank you. So now I'll be doing a demonstration of the UI of our IoT application project. So first up, we have 3 screens. So first one is the dashboard, preferences, and then the settings page. So for the energy dashboard, it basically displays all the data that the user will be able to see at a glance, and it consists of like the most important data that the user will need for our application. So I'll go through them. So the first one is the connections. So basically they'll be able to assign the Tuya plug to an appliance. So I can do it here. So for example, Tuya plug 1, I can select television, and then Tuya plug 2, I can select toaster, and Tuya plug 3, I'll select the fridge. Okay, so that will directly link to the active appliances. So basically, the Tuya plug 1, 2, and 3 are representative in the graphs. So actually, we'll be producing live data whenever the user is viewing it. So Tuya plug 1 will be represented by this, so they can also see how much energy is being consumed at this point of time. Okay, so next up, we'll move on to the cost prediction. So what we did is we used like an average cost in Singapore, and then we calculated that according to how much energy is being used by the user. So this is like the cost prediction that they can see as well. And then next up is the cost saved. So we just wanted to show a comparison chart of like before of like a monthly basis, so they can see how much cost they expended on each month. So maybe as the more they use the application, the more cost that they can save, because it will help them to reduce their energy usage. And then the last feature that we have is the smart tips. So for the smart tips, we plan to change it like either every half a day or every day, so that they will be able to use these smart tips and apply it into their everyday use. And having different tips will help them to gain more information as well, instead of having just one tip. Yep. So next one is the preferences page. So for the preferences page, we have 3 settings. So the first one is the connections. So the connections is basically just it's the same as the dashboard, but it makes it easier for them to do it if they want to do everything at once. So let's do it again. So first one is television, and then the toaster, and then the fridge. Okay. So for the max current, the max current is basically the total current of all the plugs measured and then sent to the Raspberry Pi. And then if it exceeds the maximum current set by the user, so for example now I want to put 48, okay, and then it will send an alert to notify the user of the exceeded power consumption. And they can also choose which TOYA plug to power off. And how that is done is through the next setting, which is the priority. So for the priority, they are able to set like, so I want the first priority to be the fridge. Okay, so TOYA plug 3 will be first, and then the second priority will be television, and then followed by the toaster. Okay, so when they get an alert, they can manually choose which TOYA plug to power off. However, this priority setting helps them to, for example, they're busy with like their everyday work, and then the lowest priority appliance will be switched off first, so that this allows the household to meet the specified current set by the user, which helps to reduce energy consumption. So for the last one is the settings page. So this is just a basic settings page, which consists of like 2FA security alerts, devices, as well as the help center about facts and terms and policies. So for our settings page, the main focus that we had was that we wanted only authorized devices to be able to access this UI, because we do not want like unauthorized people to be able to control the energy consumption of their house. Yeah, so we'll specify like the name of the device, and then I can save it so that only this device is able to access the UI. Okay, and now that's the end of the UI demo. Thank you.